This video aims to help you avoid getting caught up in the social media frenzy when simple numerical calculations posed as trick questions create some heated debate. Hopefully, after watching this, you won't be one of those so strongly claiming everyone else is wrong when in fact you are also wrong. Here is an example of one such question, but similar questions seem to pop up from time to time, always creating the same confusion, usually demonstrating a simple misunderstanding or misinterpretation of the mathematical order of operations. Some people just plainly don't know the correct order, while others tend to get tripped up by one of the steps in particular. Before I continue, what do you think the correct answer is? If you have a scientific calculator, you should be able to type it in exactly as it looks, like this, and the calculator should give you the correct answer. I say should because some very basic, cheap models might not have the correct order of operations programmed into them. So what did you get? The correct answer is 1. You may have noticed there is now an extra pair of brackets on the calculator's screen. This happened automatically when I pressed equals. It's the calculator's way of clarifying how the correct order of operations has been applied. And in fact, this highlights exactly where most people have been going wrong in posts such as these on social media. Before I walk you through it, let's investigate the correct mathematical order of operations and see why they are so important. It's not just about winning arguments on social media. By the way, I think the most common incorrect answer given for this question is 16, and we'll soon see why. The order of operations is basically a set of instructions that tells you which mathematical operations take precedence over others, and thus should be calculated first. The aim is simple, to make sure we all get the same answer. And, when followed correctly, we do. For a more detailed understanding of the order of operations, I recommend you watch this video. In school, you probably learnt a simple acronym or mnemonic to help you recall the correct steps to follow. There are various versions of this, depending on which country or even which state or region you were educated. The 3 most commonly used are BODMAS, BIDMAS, and PEMDAS. BODMAS stands for brackets, orders, division and multiplication from left to right, and addition and subtraction from left to right. BIDMAS is almost the same, with the I representing indices, in other words, powers. Both these forms are common in the United Kingdom and Australia and other Commonwealth nations. The P in PEMDAS stands for parentheses, being one type of bracket, as we will soon see, and the E is for exponents, being another name for indices or powers. The other slight change is that multiplication and division have been interchanged, which doesn't really matter, since they are to be performed as they occur from left to right, and before we do any additions and subtractions. Canada and New Zealand use a slight variation of this, BEMDAS, with B again meaning brackets. The number of different acronyms perfectly highlights where the confusion in interpreting the order of operations lies. It's in the first 2 steps. The brackets and orders, or powers or exponents, are really intended to include all mathematical groupings and orders, not just brackets and powers. In fact, there is a newer and more descriptive acronym circulating, GEMDAS, with the G now representing grouping, and thus covers all forms of mathematical grouping, not just the various forms of brackets. So I'll stick to one of the more traditional cases, referring specifically to BODMAS from here on. The most common grouping symbols are brackets, which can take on various forms and actually have different mathematical names, although they are all often simply referred to as brackets. Square brackets, parentheses, and these are braces, more commonly known as curly brackets. The advantage in using different brackets becomes obvious when we have more complex calculations like this one, with brackets nested inside other brackets. Using only parentheses, like I have here, can make it more difficult to see the matching pairs. That is, where each pair starts and ends. Color coding, we can see the matching pairs more clearly now. But using the three types of brackets, like this, helps match the pairs quite simply without color coding. In any case, you need to calculate the innermost brackets first, systematically simplifying the remaining calculation until you reach the final answer, here. If this confuses you, reach for a decent calculator. Keep in mind that within any of these grouping symbols, the entire order of operations applies again. So for example, within a pair of brackets, not only might you have more brackets, but there could be powers which need to be evaluated before moving on to any multiplications and divisions, and then lastly, any additions and subtractions. If the power is outside a pair of brackets, then those brackets need to be calculated first before applying the power, and so on. Remember, if things are getting complicated, reach for a calculator. Returning to our original example, with only one set of brackets, we would expect that the order is obvious, yet people are still achieving different results. It's not really the order of operations that is causing the problem here. It's a misunderstanding of mathematical and algebraic notation. These special notations form part of our first two steps in the order of operations. It's not just brackets and powers that form groupings and orders. Square roots, cube roots, and so on are also orders, and in fact they can be expressed as powers. But why and how is the subject for another video. Next we have fraction notation. The fraction line, known as the vinculum, means division, but it also acts as two sets of groupings each side of the division. And if we replace the vinculum with a division sign, then we would need to place the top and bottom in their own sets of brackets, and sometimes around the entire thing. Watch the in-depth video if you'd like to know more. Our original problem does not include any fractions, so I'll not complicate things any further. The mathematical notation that is causing the problem is the process of leaving out multiplication signs to simplify an expression. We can do this between numbers and variables or pronumerals, which are unknown numbers, or outside brackets, which is what we have in our featured social media example. We also do this in other situations too. When we do this, we are forcing a grouping, and the product involved effectively becomes one item. It's as if there are invisible brackets around them. This is because the product needs to be calculated before any further calculations can be applied. Showing these invisible brackets in our original problem clarifies the order of calculations we need to follow. Good calculators will do this automatically, as we have already seen. You were likely taught to rewrite the multiplication sign when evaluating the expression, and this is exactly what people have done to achieve the incorrect answer of 16, as we see here on the calculator screen. They have forgotten about the invisible brackets. So, following the order of operations correctly gives 4 for these brackets, then 8 divided by 2 is 4, and finally 4 multiplied by 4 is 16. If we put in the extra brackets, we again achieve the correct answer, even with the multiplication sign shown. We do the 2 plus 2 first, then multiply that by 2, giving us 8 inside our invisible brackets. Lastly, we do 8 divided by 8 to achieve the correct answer of 1. Typing it this way into the calculator will also give the correct answer. Remember to watch the detailed video if you really want to understand the order of operations. Alternatively, go out and buy yourself a decent calculator. Clearly, all the debate could have been avoided if the writer had simply included the extra invisible brackets. But how much fun would that have been?